All right, so this is the second practice problem. This one's located in Louisville, Kentucky. So slightly different problem. Here we have 2.5 acre forested land. And what's going to happen here, it's going to have a 20,000 square foot asphalt parking lot and then a 3,000 foot bike shop with a shingle roof. All right. And here we're going to be using the 10-year 1 hour rainfall. All right. So for 10-year, the adjustment factor is just 1.0. Oops. Use the pen. 1.0. C for farmland. Or sorry, not farmland, forested area. So you go to forested area. It's between 0.59 and 0.059 and 0.2. So the average there is 0.059 plus 0.2, all divided by 2. So you go ahead and do that average, and you get approximately 0.1295. It's so 10-year 1 hour rainfall, 10-year 1 hour. You see that the rainfall is 1.96 inches per hour. Inches per hour. And then we have 2.5 acres. All right. So Q pre is equal to 1.0 times 0.1295 times 1.96 times 2.5. So Q pre is approximately 0.63 cubic feet per second. All right. So still using, for post-development, still using 10-year, so it's 1.0. C sub C. So now we, let's see. So the sub area, we have the parking lot. Let me actually put that somewhere. So here we have parking lot, shop, and the remaining forested area. All right, so let's make sure we have the areas correct. All right, so it's going to be a 20,000 square foot parking lot and 3,000 square foot bike shop. So we have 20,000. A1 is 20,000 feet squared. A2 is 3,000 feet squared. A3 is the remainder. We'll do that later. So remember, divide this by 43,560 to convert it to acres. So 43,560. And when you do that, so 20,000 divided by 43,560, you get 0.46 acres. 3,000 divided by that is 0.07 acres. And so you get 2.5 minus 0.46 minus 0.07. You get a remaining acreage of about 1.97 acres. All right. C sub 1. So for a asphalt parking lot, remember the worst case scenario was 0.95. C sub 2 for a shingle roof. Go back here. We have again 0.95. And we're going to use the same runoff coefficient as we previously calculated for the pre-development, 1.1295. All right. So to calculate this, it is 0.46 times 0.95 plus 0.07 times 0.95 plus 1.97 times 0.1295, and all of that divided by the total area of 2.5 acres. Okay. When you do that, you should get approximately 0.30. It's still the 1.96 inches per hour. And the total area is still 2.5 acres. All right. So Q post is CF, which is 1.0, C, which is 0.3, the composite, right, 0.3. The I, which is 1.96, and the total area is 2.5. Multiply all those out, and you get approximately 1.47 cubic feet per second. All right, what is the difference in the pre and post? So the change in runoff is Q post minus Q pre. Let's double check again. We have 0.63 for the pre, so it's 1.47 cubic feet per second minus 0.63 cubic feet per second. Do that subtraction, and you get approximately 0.84 cubic feet per second, which is an increase. Again, it's a positive number, so it's an increase. And now one more time, let's figure out the total volume. So it's 0.84 cubic feet for every 1 second. Multiply that by 60 seconds in every 1 minute. And multiply that by 60 minutes in every 1 hour. You do this for a total of 24 hours. Placeholder of 1. So seconds divide out, minutes divide out, hours divide out. You're left with just cubic feet. 0.84 times 60 times 60 times 24. Do that multiplication, and you get approximately 69,120 cubic feet of water that you need to store on site. All right, so that's problem number 2, and you got one more problem to do for practice.